Artificial neural networks. Artificial neural networks, as clear from the words, are the artificial implementation of the brain's internal architecture, which we called as the neural network of the brain. So the idea is the way birds inspired the design of planes, the neural network can help in shaping artificial intelligence systems. Artificial neural networks, ANNs, are a subset of machine learning and are at the core of deep learning. They are behind the highly complex machine learning tasks such as classifying billions of images on the internet, powering speech recognition devices, recommending videos posts trends to millions of users on their feeds, based on their previous interests, or playing and competing with some Asian world champions on their traditional mind and strategy-related games, like chess or Go. Wikipedia says that artificial neural networks, ANNs, usually simply called neural networks, NNS, or neural nets, are computing systems inspired by the biological neural networks that constitute animal brains. Now the question is, how do they work? ANNs are made up of interconnected nodes, called neurons or artificial neurons, which process information and communicate with one another through a series of connections, called synapses. The whole structure loosely models the neurons in a biological brain. Each connection, like the synapses in a biological brain, can transmit a signal to other neurons. An artificial neuron receives signals, then processes them, and can signal neurons connected to it. The signal at a connection is a real number, and the output of each neuron is computed by some nonlinear function of the sum of its inputs. The connections are called edges. Neurons and edges typically have a weight that adjusts as learning proceeds. The weight increases or decreases the strength of the signal at a connection. Neurons may have a threshold such that a signal is sent only if the aggregate signal crosses that threshold. Although the ANNs have become popular in recent years, we can trace back to their origin in the period of World War II. They were first introduced by neurophysiologists Warren McCulloch and the mathematician Walter Pitts back in 1943. In their research paper, A Logical Calculus of Ideas Immanent in Nervous Activity, McCulloch and Pitts presented a simplified computational model of how biological neurons might work together in animal brains to perform complex computations using propositional logic. This was the first artificial neural network architecture. Since then, many other architectures have been invented. The future of artificial neural networks as a domain is bright and full of new possibilities. Now, with the growing use of the internet and smart tech-related products, there is a huge quantity of data available to train neural networks, and the quality of training algorithms has improved with time too. And combined with that, the tremendous increase in computational and processing power, and flooding of funding and investments in the field, all are contributing to this current trajectory of ANNs, which looks promising. To understand how the artificial neural network works, one must get some basic idea about the internals of the brain structure. And this is something that we will cover in the later parts.